If it looks like I'm not listening to you, it might be that my speaker went to sleep. So then just quickly just type in to the chat window that Mr. Walks, turn on your speaker. It's just a quirk with my speaker there. All right. So as of yesterday, let me close some of this stuff. Our 40S class, I did update this little piece right here. You can see here on yesterday, Thursday's class, we continued advanced classes, and there is a recording of that class that you can find on our webpage if you want to review anything we did yesterday. Also, GitHub is up to date now. So if I now go from here back to Computer Science 40S, and source, for example, of the testing class, it should have in there up-to-date code from where here you can see where we worked on the static method yesterday, and we ended up calling it in various ways. Okay, and all the information about static methods is there, right? And I'm going to review that just a little bit because it is a big concept here. And I'll just move this out of the way and bring in the stuff we did, our checklist, because now I want to put a check mark beside the fact that we have studied the concept of the static method. Okay, so the static method, and I'm going to put a check mark beside the word static here, is now a concept that we've seen. Static as a method, static as a variable or as a property. And we're going to move forward in our checklist now from there. And as you can see, we've been checking off quite a bit of our checklist here. Okie dokie. No one's interrupting me, so I assume I can just move forward now, which I will be doing. I want to talk a second. This will help tie in what we did with the static method and the static property about a little bit about how memory works. So let's talk about memory the way I described it to you at the 30S level, or even at the 20S level. So when I first taught you about variables, I would say, okay, here's a line of code, int x equals 10. And the way I would kind of draw it for you to visualize it would be like, okay, here's this box, it's got a 10 in it, and the box is X, sort of like a mailbox or something like that. That helped you visualize the concept of a variable, okay? When you guys got to arrays, as I am doing with the 30S just a few minutes ago, I would help you visualize it as just a series of boxes, but you had to also visualize the little index numbers. Then when you got to the unit called classes, as we are in now, more advanced classes, you can visualize it in memory as it's kind of a collection of boxes of other boxes. It's a data structure that if you look at this class foo, it has an integer, a double, and a character array, that when I make a new foo object called A, it is a collection of the integer, the double, and the character array all grouped together into a structure, okay? So you have to kind of visualize the memory in different ways. Now, what a computer's memory actually looks like is, again, a series of little boxes, like compared to lots of little mailboxes. And each box, each memory location has an address where it can store the contents. That's how a computer works. It is an electronic device that stores data in little boxes, okay? Some boxes, like strings, require more address space. An integer or Boolean would require less space, okay? Now, as we move into the 40S course, I want to expand that visualization out a little bit. When you think of a memory location, think of it as really two locations. One stores the content, the other stores the actual name or the reference to that particular content. So when you think of a mailbox, it has the content inside the mailbox, but also the address on the mailbox itself, or what I'll call the identifier name, or its ID. And obviously those two things are connected. Your identifier connects to the contents. If you can start to get visualizing it this way, it'll help not only in this unit, but in the next unit as well. And in obviously in more advanced computer science moving forward. Okay? So maybe think of a class like foo as an identifier name connected to another identifier name connected to its contents. Okay? The contents is what matters, right? That's what's being stored inside the computer, but how we get to those contents is important. So this relates to the keyword static that we just talked about. Static can be used as applies to variables or data structures, to methods. We did both of those. There are also other things that static can be connected to, named blocks and named classes, or pardon me, nested classes. But those are things I don't want to get into. They're not that widely used things. We're not going to look at those, okay? So in this slide, it describes some of the stuff that we already put into our example about how static methods and how static data structures work. Here is the code that we also put into our example, both the student class and a end of the world method in the person class. We already did that, okay? But here's the visualization. If I was to create 4 different student objects, Sally, Peter, Matt, and Katie, each of those objects would have their own memory for the name, the age, and all that stuff. But all 4 of those objects would all share a reference to the same static variable called total students. So they would all share a connection to the same piece of memory. And that's what I hope you visualize when you think of a static object, okay? All right. Forgot to start the timer. That's okay. What is it, 11:37? I'll just reset the timer right now. Let's go for another 3 or 5 minutes. Let's go for another 5 minutes. Okay, now I have the timer ready. So in 5 minutes, I just want to add a little bit to our example, which we'll expand on Monday. And what I actually want to expand on to our example is some more classes. Some more classes that we aren't really going to do much with other than make the class itself. We're not going to really add any code to the classes. We're just going to make them so that we can expand out on what we have so far. Like we have a person and a student and a teacher. Let's build more classes to connect to those, and then we'll interconnect the classes. So for example, let's make a class that will be a child of the student class. So it is a student. Let's start with that. Let's right click, new Java class. And let's make a high school class. High school, I can't spell. High school. But this will be a high school student. So we will later on Monday put in the code that says high school extends student. And since student is already extending person, we're going to have multiple levels of inheritance going on there. But anyways, let's just do that. Let's not even worry about the code itself, but I want you to add a class called high school. Then I want you to do it again. New Java class, Husky. A Husky, which is what a Sturgeon Heights student is a high school student. It's a specific type of high school student. So we'll click finish. And again, we're not adding any code, but we will on Monday start to interconnect this class. So Husky is a high school student, but we want something to compare to that. So there are other high school students other than Huskies. So let's just go down the road, the closest high school to Sturgeon Heights, John Taylor. And John Taylor's mascot isn't a Husky, it's a John Taylor Piper. I know, it's a weird one. So let's make a class called Piper, okay? What you'll start to see as we work with this, that Piper is a high school. It will be connected through is. And Husky is a high school. High school is a student, and a student is a person. So there'll be levels of inheritance going on here, okay? Now let's go all the way back to person, okay? Let's create a different type of person. So a new Java class, Let's make a doctor. Doctor is a person, okay? Let's make a new Java class a baker. So again, we're not going to do anything with these classes other than connect them together so that we have lots of classes for where the example's going next. So we have a baker, we have a doctor, we have a high school, we have a husky, we have a piper. Okay? I want to make another class that's a different type of teacher. So right click, new Java class. Let's make a Mr. Walks. That'll be fun and a little bit degrading. But let's make a Mr. Walks that will be a teacher. And I think that'll be good. That'll be a good way to go. So before we wrap up today, we're going to have a baker, doctor, high school, a husky, and a piper, and a Mr. Walks. So please make those classes. And then one more in the last minute here. Right click, new Java class, meeting. Okay? Class called meeting. And meeting not going to be connected to the other classes in that sense. It's not going to inherit from the other classes. Okay? These are the classes I want you to make. Baker, doctor, high school, husky, Mr. Walks, piper, and of course, meeting. Okay? These are classes you should already have. You should already have teacher, and you should already have student. You should already have book. Those classes we already have. Please make those classes. You don't have to code them at all. I don't know if you hear in the background, that's my gong going off. And then on Monday, we'll draw up a diagram how all these interconnect to one another. And then we'll be using that as part of our example, because just using student, teacher, and person. Oh, by the way, that's another class you should already have. You should already have person. Isn't going to be enough to kind of really visualize what I want to do with our example at this point. But don't worry, we're not going to be writing a whole bunch of code in these classes. We're really not going to be writing any code in these classes other than the code to connect the classes together. All right. At this point, I'm going to say to you 40S students, I will be on the line for the last few minutes of class here today. But other than that, that's where we're going to leave our example. Yes, I will update GitHub with these things, but really, I mean, there really shouldn't be that much you guys need off of GitHub there. It'll be on Monday where we start actually putting in the code. Have a good weekend. Stay out of trouble. And for any of you 40S or 30S students still on the line, I'll be available at 3 o'clock today. If you have any technical issues or need any help with anything, you can contact me and I'll be helping with that. But it is Friday, everybody. So I'm also going to make this offer over Teams for the bad joke of the week. As a matter of fact, you know what? Bad jokes of the week are by definition bad, neither repeated nor explained. You don't like them, get them, or hear them. It's not my fault. And usually at this point, I ask if you want to accept or reject them. But I'm not going to ask that today, because if you don't want to hear the bad joke, you can leave Teams right now and have a great weekend. But if you do want to hear the bad joke of the week, you can stay on the line for the last few minutes here. And if you need help, you could mute your speakers. You have the control. You have the power right now. Because why did the ant fall off the toilet seat? Because he got pissed off. For those leaving now, have a great weekend. It's going to be beautiful out this weekend. Go Jets, although I'm a little worried about how that's going to go. And I will see you guys on Teams on Monday. Anyone else who needs, I guess I better stop the recording as well.